Hey guys, so here's an instructional video to help you with the 9.8 checkup and quiz. This one I feel like is a little more important because there's a lot going on because it involves I'm using logarithmic rules and exponential rules, so I kind of want to like make sure we're okay with that. And then we're gonna look at some examples using logs, probably towards the end, and then recall or change of base formula. I know we kind of went over this in class before we left, but let's just do some examples with it so I know you guys are on track. So before anything, I want to make sure you guys are okay with exponential rules. Like go back to it, so you know if it has the same base, you can add the exponents. If here's a small example underneath it, so you can use it for your notes. Quotient rules, the same base, different exponent, you just subtract them. 7 minus 3 is 4. Power rule, in parentheses, power to a power, you multiply them. Here's an example. And the negative rule, if you have a base to some negative exponent, you're going to flip it, the reciprocal, and do 1 over that same base to the same power, but now it's positive. And here's a bottom example too. Okay, and the zero rule, of course, if anything is raised to the zero power, it is just 1. So you got that now. So like that's would be useful for you if you don't remember that. Something you might need to take into account, and something I probably should have done earlier too was make a show you the logarithmic rules to solving exponential equations. Okay, so just like how there's exponential rules, there are also logarithmic rules. So let's say you have a product inside a log. Like let's pretend there's parentheses in here. Actually, let's say you have like some sort of product in here, right? I mean not perfect, but you said so you have log base b, whatever that base is, and then you have m times n. Well, you can split that into a sum. That for instance, they're both gonna have the same base. It's gonna be log of the same bases, and you're gonna separate it with addition. So what I like about this example is because they show you what I like about this rule image is that they have an example. So let's say you have log base 3 of 9x, okay, 9x. You can separate that as a sum. So now you have log base of 3 of 9 plus log base of 3 of x. So now it's split that up. Now and that's if you have a product, right? So if you have a quotient, you have now that turns into subtraction. So the bases would be the same, and then it will turn into subtraction, splitting up that quotient with whatever value is m and whatever value is n. So here they decided to use a fraction as your base, and your quotient is 4 over 5. So now that gets split. 4 minus log base of 1/4 of 5. So if you have a quotient as a log, so then you would turn it into subtraction. Now let's say you have a power inside your log, because some of the examples we might do might have a power in them, so I want to make sure we're okay. So here is now you have log base of b m raised to some power, whatever it is, p for power. So that's the same as you taking that power out and pulling it out, and now you have p times log base of b into the m. So I pretty much took that p and turned it into a product. Remember the dot means product, so I pulled it out and made it a p times whatever the log base of bm is. So here's an example. You have log base 2 of 8 raised to some power. That a is raised to a power. Okay? So now what I did was I pulled that x out, and now it's a product. X times log base of 2 of 8. That doesn't mean you're going to take this and turn it into this. That doesn't mean that, okay? I want to emphasize that this is just a product, okay? You don't have a product in here. It's not 8 times x, 8 to the power of x. Okay? That doesn't mean the same thing. Okay? So don't confuse them. Okay? I want to emphasize that. Just because you pull the x out, that doesn't mean now you're going to turn it into sum. Okay? That doesn't mean that. Okay? Now, if you have a log base m, and that same log has the same base and is a different value, then these two are the same thing. So that means you have a log base of 8, and this other log has the same base. That means that you can set the two values inside the two values inside your parentheses equal to each other. So now you have 3x minus 4 equals 5x minus 2. And in here, you can solve for x. So if you have two logs equal to each other, and the m and the n are the same, so they have same base. 8 is equal to 8. That means I can set m equal to n. So m here would be 3x minus 4, and here would be 5x plus 2. Okay, so those are your logarithmic rules. Keep these in mind when you do the examples. Okay, so now let's do some examples. So what we're gonna do now is I want to do the example from your study guide to make sure it makes sense. So now you have 10x equals 190. Okay, and we're gonna solve the exponential equation. Solve exponential equation. So now we're gonna use logs. Okay, so now we're gonna take the log base of 10, and we're gonna put that in parentheses. So now we have log base of 10 of x. So if I'm gonna take the log base of 10 to this left side, and then I'm gonna also have to do it to the right side. So log base of okay, log base of 10 of 190. Okay, mind you, you're gonna have your calculators with you, so you'll be okay with this. Don't forget I gave you a link on Google Classroom for this. So now here, okay, if you have if you set this equal to each other, if you have the same base and then it's the same base here for some power, then all you're left with is x. Okay, and why is that? Because log 10, 10x. So 10 to what power will give you oh, that's not making sense. So let me just go back real quick. So I guess it's a rule that I don't have here shown. Okay. If you have some log, okay, if you have some log with the base, and then inside the parentheses it's the same as the base here, then that's just going to be 1 times x, which is what I have here. 1 times x. Okay, so now if I'm using some log here, it better be the same here. So let's say if I had log 3 of 3x, then this would just be 1x again. So if they have the same, this base is the same as this base in the solution, I mean inside the parentheses, then it'll just be 1. So on your calculators, you should be able to use on the website, if you do log 190, that's the same as log base of 10. So if you do that, so let me just show you. Let's go to the scientific. I'm at calculator.com. So you can do where's my log here? Here we go. Oh wait, hold on. I gotta put the number first. So you're gonna put 190. You're gonna take the log. This means log base of 10. So this would be what the solution would be for log base of 10. 190, type in the log. So then let me make this full screen again. If I round, it should be 2.27875. So again, if you have some exponential equation, if you set the base log 10 and it's the same as inside the power, you just get x out. Okay, so now that would kind of be like the inverse. So like the exponent has a base and power, the inverse would be log of that same value inside the parentheses. Now, what if you had e to the x equals 8? Okay, we're gonna take the inverse for e would be natural log, the inverse for that, and that means I have to take the natural log of 8 because whatever I do to one side, I do to the other. So if you ever see an e, the inverse is natural log. So these two would cancel, and then you're left with x equals natural log of 8. And then on your calculators on the website, let me clear this. So if I do 8 natural log, the button's right here. That's my solution. 2.07944, but we'll just round. We get 2.07944. Okay, so we'd use this idea, right, of it being the inverse operation. So like just like if you add the inverse operation subtraction, if you do division, the inverse is multiplication. Same thing here. If you have a base e, then the inverse is natural log. And for this back here, doing the log of that same base would make this go away, and all you're left with is x. So same idea there. Okay, so now I want to do an example with one of the checkups. Okay, so I have, actually I want to do one with change of base formula. Okay, so remember the change of base. If you have some log, let's say of whatever that is, we'll call it c, and then this is going to be a. Okay, you're gonna do the log. I would use base 10. You want to use a common base. C would be common base. Well, if I'm gonna use for a common base, then maybe I should call this something else. So let's call this let's do the, let's still call this B. How about that? Keep it the same. Okay, let's call this B. So let's say you have some base here and some solution to it. So then you have log. Okay, we're gonna find the common base, and then this numerator is gonna turn into a fraction. It's gonna be A, and then we're gonna do the same thing. We're gonna find a common base, that same common base, and then the denominator is gonna be this base that was originally here. So this top part goes over here, and then your common base. So normally what people like to do is use common base of 10. Okay, always on the calculator. So okay, so we're gonna use this idea and look into the steps. So here we have. So let's do an example. We're gonna use this idea. So let's say you have 3x equals 0.25. Okay, we're gonna use the inverse. So if it's an exponent, we're gonna do log base of 3x equals 0. Oh, well, whatever you do to one side, you have to do to the other. Equals log base of 3, and this is gonna be 0.25. Okay, so now, okay, so this has a power, so just like the logarithmic rule, this is gonna come out, okay, and then log base of 3 as inverse, so they're gonna cancel, just become 1. So now I just have x, okay, so now I have x equals log base of 3 and 0.25. Okay, so on my calculators, normally I don't have log base of 3. Like, we don't have the graphic calculators from school. So we're going to use change of base formula here. So here we're going to do x equals log 0.25 divided by log 3. And our common base here is 10. Okay, here C is 10. You just don't see it because on the calculator you're going to type it like so. Log, we'll find 0.25 log first on your calculator, and then you're going to find uh, log base of log 3 on your calculators. And then if you do this correctly, your solution should be negative 1.26186. Okay, so I would just do this top part first on the calculator, write it down somewhere, and then when you find that answer, you're gonna find this answer, 3, and then click the log, and then you're gonna get a solution here, and then divide those two numbers to get the solution out. Okay, but if some of you have scientific calculators at home, by all means type it in this way. But if some of you don't, remember that here on this calculator on this website, okay, you have to type in the number you want first, like 0.25. I want the log of that. Oh, it was 0.25. Hold on, 0.25. Where is it? Oh, I get 0.25, and then I want the log for that. So I would write this answer somewhere, and then do the same for the second one, and then find the solution using the change of base formula. And you would only use that if you have some sort of base and some value here that you don't know how you can find, because they're like either prime or they're not easy to find on the calculator. So we can use the change of base formula. Okay. So now let's do just like one example from the checkup. So you have, let's do like one that looks kind of difficult. Mm, how about you have, I don't want to spend too much time on this because so now I have 4 times e to the x equals 7.5. Okay. Well, remember order operations. If this is multiplication, how can I get rid of this 4? Well, just divide. Boom. E to the x equals 7.5 divided by 4 is 7.5 divided by 4 is 1.875. Okay. Now, what would be the inverse for something having a base of e? Well, it would be natural log e to the x. And whatever I do to one side, I have to do to the other. So natural log of 1.875. Okay. So now I have x equals, it'll make this go away. Now I have just x. So I want to find natural log. So it'll be 1.875. And the natural log of that would be 0.62 0.86. So that would be my solution to the exponential equation. Okay, so we're using logs to find some sort of solution. Okay, and if it's something easy like let's say you had 2x equals 8. Let's say it was something easy like this. Well, you could use the same rules we just used, but you also know that 8 is the same as 2 cubed, right? Because 2 times 2 times 2 is 8. Well, if they have the same base, then x just is 3. That's another way to do it. So just keep in mind of that. So we can use logs, and sometimes we could use basic exponent rules to figure that out. Okay? So that's for you. So good luck with the checkup and the quiz. Okay? And if you have any questions, just leave a comment with the instructional videos.